please tell me. And chat's okay too. But I do love hearing your voice and hearing us engage, verbally over it. So feel free to turn on that mic and ask or tell me if you need me to slow down or ask, hey, I don't get this. Stop and go over it again. Stop and answer my question. Let's do it together. So let's see. Did I get anyone else? Xavier, Tatiana, Savannah, Jacob, Anthony, Levi. Cool. So we're starting Unit 8 today. In Edmentum, this one is called Lines, Angles, and Mathematical Proofs. Quick poll question for you guys, and I want to hear from everybody. It's just a yes or no question, even though I'm not supposed to be asking yes or no questions to the group. But yes or no, can you tell me in the chat, have you ever heard of proofs in math, or have you ever done proofs in math? Yes or no? Go ahead and type it in the chat. Have you heard of it before? Have you had a sibling or parents talk about it or hear about it, a friend, or done it in class before? I just want to gauge where you guys are at if you've heard this term before. There's 3 of you. There's 4 of you. Yes or no? Have you heard of math proofs or used them before in any capacity? Victor, good morning.
Good morning, teacher.
Glad you're back. So, Victor, our lesson today is called Lines, Angles, and Mathematical Proofs. And we're going to start in just a minute. Before we do, I want to ask you, Victor, and everybody, have you ever done math proofs before, or have you heard of them before?
I don't think so.
Yeah, okay. No worries. I'm not expecting anyone to know about them, but I know it's a topic that you've. Oh, good. A lot of no's. Terrific. That's good. Um, I'm happy about that, actually. Okay, I've got my notes ready. So we're going to be doing some stuff today and in this unit, folks, that might not seem like math to you. Okay? Our focus for Unit 8 and Unit 9 is going to be our reasoning, our logic. Okay? If one thing leads to another, which leads to another, which leads to another, that means the first action led to the final action. It might seem weird to you, and it might seem like overthinking and over like explaining, but that's a good thing. That's what we need to do when we're doing our math proofs. So I just want you to start thinking about that right now before we put anything else on paper, okay? Before we start. It might not seem like math. It might be weird at first. It probably will be weird. It was weird for me too when I started doing them myself. But the more I did it, the more I enjoyed it, and the more I understood like the point of it as well. So, with that all said, that's my disclaimer for today. We're going to be covering how to write a math proof, and we'll do lots of examples together of doing math proofs. We're going to define some new terms that, for our group in geometry from last unit, I think are new for us. So, we need to define linear pair, supplemental angles, congruent, and vertical angles. When we do these definitions, I'm going to ask that you guys, with your mics off, you don't have to turn on your mic, but with your mics off at home, I want you to just practice using the language, okay? Saying it out loud. Don't just read it. I want you to practice saying it out loud just to get used to it. Linear pair, supplemental angles, congruent and vertical angles. So we'll define those as we go on. And then last up, we're going to just really briefly look at different styles of math proofs, okay? We'll mostly just be doing one of the styles, but I want to show you that there's several ways to write them. Now, before we even start with a math proof, let me skip to the end so I can get to a blank page. There we go. let's do a quick non-math proof, okay? So I'm going to put some stuff on the screen, and I want you to just work this out with me and think it through with me. That's all I'm asking. So let's try to prove something kind of obvious and maybe even silly. Prove with logic, okay? We're going to connect one thought to the next. I want to prove with you guys now. Oh, something in the chat. Tatiana, yes, I'm going to go back to the last screen right after we finish this, okay? And then we'll go back to that last screen. So I want to prove if it rains, the ground is wet. If it rains, then the ground is wet. Now, you might be thinking, I've lost my mind. First, let me just ask you guys as a group, is this true? Does this seem true to you? If it rains outside, the ground is wet. Is that true or not true? Go ahead and type your answer in the chat or turn on your mic and answer really quick. If it rains, the ground is wet. True or not true?
I think it has to be because it has to be wet from the rain
Very good.
or lakes and other
Exactly.
stuff.
Yeah. Like right now, you look outside your window. I'm looking outside the center here, and it's pretty sunny. It's pretty like there's no rain, obviously, where I am. I don't think it's raining where any of us are. True. Yeah. Levi, Tatiana, Savannah, Jacob. Yes. And Anthony verbally. Thank you all. Yeah. This seems true, right? But we need to overthink this a little bit and prove it logically. To prove for sure that when it rains or if it rains, the ground is wet. So let me ask you guys kind of in a step-by-step way. We're going to start with this, and I want to end with the ground being wet. Start with assuming that it's raining, or assume that, assume that it's raining. Or I guess we could also say when it rains. Assume that when it rains, what happens when it rains? So think about that question. And again, I am asking you to overthink this and over-explain. So pretend with me, close your eyes, and assume it's raining outside. What's happening when it's raining outside? What does rain even mean? When it rains, Anthony mentioned lakes and rivers, but for rain, we're talking about not water that's already on the ground, right? It's up in the...
You needed to go through the water cycle in order for it to fall from the clouds.
Exactly. Okay, thank you, Levi. Water is falling from the clouds. Assume it's raining. And therefore, because it's raining, water is falling from the sky or from the clouds, from above. Oh, sorry. I can't spell when I'm excited. Clouds. Water is falling from the clouds. So assume it's raining. Here's our drip drops of rain falling. That means that water is falling from the clouds. Okay, so water is falling from the clouds. Where does it go? Does it just go forever, like straight like through the earth or something? I might have covered you if someone had their mic on. Go ahead. If the water is falling from the clouds, where does it go? What happens next? I am asking you to overthink this and overanalyze this. This is our process. Oh, go ahead, Levi.
Anything that is basically a solid object is getting wet.
Yes. How about and think of the water, it's falling from the clouds. It's basically going down straight, right? Straight line downwards. And it's hitting those solid objects that you just mentioned. Everything solid, can we say below the water, is getting wet. Water is getting wet. Okay, good. We're doing good. And now we're trying to prove that the ground is wet. So I'm going to state to kind of bring this together, and there's something in the chat. It falls to the ground. Good, Savannah. Yes. And I like that Levi has that extra, the step that they came up with. Everything solid below the water falling is getting wet. And now Savannah said, well, the ground is getting wet. The ground is something below the water. Let me put that in here. The ground is below the water. So now, therefore, we've got this logical chain of ideas here. All we've started with at the very top was assume that it's raining. Assume it is rains. I'm sorry, assume it is raining. Raining. A little too excited today. Assume it is raining, and that tells us, okay, well, water's falling from the clouds, and that means everything solid below the water is getting wet. The ground is below the water, and so finally we can say, therefore, the ground is wet. We started up here with our assumption of what is happening, and we ended down at the bottom by showing through step-by-step process that the ground is wet when it rains. We've proven that the ground is wet, starting with just assuming that it's raining. And yes, you might be thinking this is obvious. And a lot of the times, these proofs are actually going to be obvious. Like you're going to be thinking, well, of course it is. Of course this is true. But we need to try to break it down into smaller steps and to show step by step how we get there. Because if I'm an alien from outer space or from a different dimension where things behave differently and different physics and stuff, I might not understand what this means. If it rains, the ground is wet. But if you can show me in a step-by-step process through these steps in the middle here with the arrows, why that's true, then we've just proven it's true. Anaya, can you hear me?
Yeah, I can hear you now.
For sure. I'm sorry. I saw that you joined at least once before, maybe twice. Sorry about the connection. So Anaya, go ahead and take a screenshot or a picture of this. What we just did was walk through a non-math proof, proving if it rains, the ground is wet. And it seems really silly, maybe to you or to anybody. It's silly to me, but we need to be able to show in a step-by-step way how we know. If all we know that it's raining, that leads to the conclusion, the proof that the ground is wet. And so that's what we've done so far. And now we're going to try an example using an algebra problem, just solving a short equation. And
Okay.
also someone else wanted to go back to the first slide. So I am going to go back to our first slide just to kind of overview what we're doing today. So last call for everybody. If you're taking notes, go ahead and try to wrap those notes up. Sorry to be fast. Or just go ahead and take a picture with your phones or your computers. And then we're going to look at the front page again and then try some math proofs. And just remember, I am going to put this up on our classroom at lunchtime. Okay, I'll do it at 12 today. So Tatiana, here's that front page again. Here's what we're going to be covering. I'll keep this up for 10 more seconds. And if anyone needs more time, just tell me. So we did a non-math proof just to kind of get the idea. And now we're going to try an algebra proof. And then we're going to do some geometry proofs using these definitions. So we'll define these as we go, okay? Linear pair, supplemental angles, congruent, and vertical angles. Okay, let's get started on an algebra proof. So writing a proof in math. This is another overview of kind of what we did with the rain and the wet ground example. We always start a proof in math with what is given. And we always call it the given in math. It can also be what we're assuming. What we assume. So it'll be one or two pieces of information. And then we're going to explain one step at a time, just like we did with our raining leads to a wet ground example. Explain one step at a time. We also are going to write our statement and our reason for each step. So in doing one step at a time, we'll write the actual statement from the math example and the reasoning for why we can say the statement. The reason is like our evidence or why it's true, why the statement is true. And then we end by stating what we have proved. So it's always going to be given some information, and then we're going to one step at a time say what that leads to. And our goal is to end by showing a certain conclusion that we've proven something using that logic to get there, using each one step at a time to get there. This is the basic layout of doing a proof. But now I want to try an actual proof using an algebra problem. So here's an example. I covered that, but it just says example, okay? So take a moment and write down what we have now. We have a given. This is what we're starting with. So we're going to start only having this equation, 2 times parentheses, x minus 4 plus 3x equals 12. Our goal, where we'll end, our goal is to show that x is equal to 4. Now, normally in math class, we just are given, or maybe we start with the equation, right? And I tell you guys, okay, now we need to solve for x. So that's what we're going to do now. We're only going to solve this equation for x, but we're going to show each step at a time, and we're going to say our reasoning for how we can do each step. And look to our list on the left, how to writing a proof in math. We're always going to begin or start with what is given. And it's labeled here. The given is 2 times x minus 4 plus 3x equals 12. And when we end, we're hoping to end with x equals 4. Okay, so I'm going to list these out with statements on the left and reasons on the right. So our logical chain of evidence, like we did with our water example, the raining leads to wet ground, we listed our statements. We didn't really list reasons for those, but it was an easier example. So now we're going to practice writing each math statement on the left with the reasoning for it on the right. Okay, sorry, here we go. So we always begin by just restating the given. So I'm going to do that here. So start with this, 2 times x minus 4 plus 3x equals 12. Now, what's my reason for stating that? It's the given. So the first step for a proof is always going to be to write the given and then state it's given. That's our reason. Now, we want to prove that x is equal to 4. We're going to use our different algebra rules and algebra laws to get there. Now, remember, everybody, when we're solving an equation, we're always going to be doing the same thing to both sides. Remember how we can add the same number to both sides or minus the same number to both sides? We can divide the same number from both sides. Stuff like that. Those are going to be our our reasons. Now, we're not going to start with that yet, though, because we have 2 times the parentheses, right? And inside the parentheses is x minus 4. Are x and 4, are those like terms or non-like terms? Can I subtract x minus 4, or do I need to, or can I not do that because we don't know what x is? Like ideally, we could just do the subtraction inside the parentheses. But in this case, we can't. So we're going to start by distributing 2 times x and 2 times negative 4. Remember that distribution? Where we start solving this by distributing the 2. So our next statement will be 2x minus 8. 2 times 4 is 8. And then we have plus 3x equals 12. Now, what's my reason for writing what I just wrote? I used distribution. So my statement is just the actual equation, and my next step, my reason is how I did that or why I did that, distribution. Okay, now we're at this stage here, 2x minus 8 plus 3x equals 12. What's our next step? Any ideas on what our next step is just to solve this equation? Should we combine any terms? And if so, which terms should we combine? Any thoughts? Can you guys share with me either verbally or with the chat? What would your next step be? What would your next idea be?
Combine 2x and 3x.
For sure. Savannah, it's like I paid you to say that, but I didn't. So if I combine them, what do we have? Can you help me with that, or anyone else? Can you help me with that? If we're combining 2x plus 3x, what does that give us for the x number?
5x.
Very good, Savannah. Thank you. Equals 12. Now, I don't mean to pick on you, Savannah, but you offered that answer. Now, I'm going to open the floor to anybody. What is it called when we combined the 2x and the 3x? Remember, we're overthinking this. We have to overthink each step and explain our reasoning.
Combine like terms.
Oh my gosh. Anaya, it's like I paid you to say that. Our reason for writing negative 8 plus 5x equals 12 is we combined like terms. Okay. Now we have negative 8 plus 5x equals 12. I want to get the x alone and get the number stuff on the other side and get the x alone on one side, right? So we need to get rid of that minus 8 or that negative 8. So what would we do next? We would add 8 to both sides, right? Plus 8 on the left and plus 8 on the right would cancel out that minus 8 or negative 8. So we have 5x. We have to add 8 to both sides, so that's 12 plus 8, that's 20, right? 5x equals 20. What was our reasoning for that? We added 8 to both sides. I'm going to start a new, not definition, but a new language, a use of our math language with you guys today. Instead of just saying adding, we're going to say the addition property. Addition. We used addition. We did 8 to both sides. The addition property of equality. Just practice using this language at home. Addition property of equality. Remember, that means we can add the same number to both sides and it's still true. Our last step is what? To get x alone. I have 5 times x equals 20. What would you do lastly to get that x alone? How do I undo timesing 5?
Division.
Division, good. So our last stage or statement would be x is equal to 4. Because if we divided both sides by that 5, we get 20 over 5, and that gives us x equals 4. What was our reason for that? We used the division. We divided both sides by some number, any number. We're allowed to do that because if we do it to both sides, it keeps it equal. Division property of equality. We started with our given at the top. Step by step, we showed the next stage, and we gave a reason for why we could do that. And we ended at the bottom with what we set out to prove. X is equal to 4. I'm going to clean that up a little bit. There we go. So we do this all the time when we solve a little equation like this. We've been doing this since last September together. Those of us who've been in the same class together, we had a whole unit or two where we were solving equations. And in our heads, we're using these reasons even if we weren't stating it out loud. Now in Unit 8 and in Unit 9, when we're doing proofs, we have to get into the habit in this practice of stating our reasons, of understanding and being able to say out loud why it is we're doing what we're doing. I don't expect any of you to be, a pro at this or love it on the first day. I do hope that you just don't give up. That's all I ask. We're going to set out to prove something for each question. We have to start with the given, end with the prove statement, and then fill in the middle what steps are getting us there and say the reasoning for that step. So I'm going to draw in purple here really quick. Notice at the top, the first line, this is where we started, and that's just the given. And it says given for the reason, because we're assuming that equation exists. And at the bottom, we've ended with what we want to prove. We prove that x is equal to 4. Okay, folks, any questions right now? Concerns? It's okay. Please tell me if you do. Any questions? Let's do this, a quick poll with thumbs. Can I have you guys really quick? I'm going to pull up my view. Where is everybody? Here, there's everybody. Really quick, can I see thumbs on how you're feeling about this first example? Thumbs up, thumbs in the middle, or thumbs down? Just a self-assessment, how you're feeling about this first proof we did with the math problem. Savannah, thank you for telling me. Levi, thank you. I want to hear from everybody. How are you feeling so far? It's just a self-assessment. There's no right answer here. Jacob, thank you for telling me. How about Tatiana and Anthony and Victor and Brooke and Xavier? Oh, and there's something in the chat. Pretty good. Okay, Tatiana and Anaya, thank you guys for telling me. Victor, Brooke, Xavier, how you guys doing? Anthony, thank you, sir. Thank you for telling me. I just want to communicate how you guys are feeling, and I would like to know. So that way,
I'm
feeling good so far?
Yeah.
Thank you, sir, for telling me. Brooke, how about you? And Victor? In the chat. Thanks, Brooke, for telling me. Victor, are you there, buddy? Okay, not sure if you're there. I hope everything's okay. All right, so now I want to take this idea of how we just did this equation solving using our proof style, and let's try a geometry example. We'll start with something smaller, and we'll work up to something bigger. Okay, so I thought this picture wasn't going to be blurry, so I apologize if it is. So what do we have so far? At the top, we've got given, I'm going to write it out in case it's not, if it's too small. AB is equal to CD, and it says BC is equal to DE. We have a picture at the bottom, so let's check out that picture. It's a line segment, A to E. So this whole thing is segment AE, but notice how it's kind of clipped up into smaller parts. I see point B, C, and D in the middle. And then there's some markings on the line segments. So the markings are showing us equal sizes. And that's just a visual representation of what is given to us above. So before we do anything else, let's go over this. So at the given again in purple, what I wrote, AB is equal to CD. That means this segment, AB, let me change to red, is the same distance or same length. It's equal to CD, which is over here. Okay, so we can assume that. And also BC is equal to DE. So let me change to green real quick. And we'll mark those. So BC is the same as DE. You might be thinking that every little smaller segment is equal to each other. It looks that way, right? It looks like every red line I made is equal to the green lines. But guys, folks, we cannot assume that unless it's given to us or we can prove it. So that's another habit we're going to have to get into when we do these types of questions and problems. Things may look equal or look the same, but unless it's told to you, like a given is, or unless we show it is, it's not true yet. Just like the rain example at the beginning. It seems obvious that when it rains, the ground is wet, but until we show it in a step-by-step way, we can't assume it yet. What are we supposed to show or prove? I'm going to change this to prove. Silly Edmentum. Prove that AC is equal to CE. So we are to show, in yellow, I want to just kind of point that out, what we're aiming to demonstrate. That AC, that's this whole chunk right here, A to C, is equal to C to E. The next one. That's what we want to show. I'm going to erase my yellow now because I'm not going to assume that until we get to the end and we've hopefully proven it. But that's what we're trying to show. All right, we'll do this in purple. So remember, we always start with the given, and then it'll take some steps in the middle, and we're going to write our reasoning for each step. And then at the end, hopefully we'll have proven what we set out to prove. Let's see. Do I have? No, I don't. Okay, so I'm going to say, I'm going to make a table on the right side. Follow along with me at home, please. Statements, make a line, and then next to it on the other side, we'll say our reasons, okay? Statements and reasons. For each statement, we should have a reason for it. Now, remember from our last screen, the first step in the first statement and reason is always just the given. So for my first statement to start here, I'm going to restate what's given. We're going to say segment AB is equal to CD. And for free, we get BC equal to DE. That's what's given. And what's my reason? It's simply that it's given. So I'm going to say given. We're assuming it. We're given that for free. AB equals CD. That means the red one is equal to the other red one, and the green one is equal to the other green one. That's BC equals DE. We're trying to show that like this whole left half, AC, is equal to the whole right half, CE. Trying to prove. Trying to show. It looks like it's half and half. It looks like AC is the whole left, CE is the whole right. So let's start by mixing together the red and green and the red and green to kind of lump them together in one group, like I did with my lines that I drew above it, AC and CE. So if we added together AB, this first little chunk, to the green one next to it, that would be AC. So let's aim for doing that. And then we can do the same thing on the right with the red and green CD, DE. Let's do this. we're given statements about AB and BC. Notice that AB, I'm looking at my statement table there, AB and BC. And if I wanted to kind of group together my red and green chunks, AB and BC, let's start by adding those together. So since we have these two little mini equations in my statements above, let's add the two equations together like this. AB plus BC. So I'm adding the two segments from the left of the equal signs, and we'll add together the two from the right, CD plus DE. So I added the left segments and the right segments. We just added across the top and the bottom, kind of like how in the fall we were doing systems of equations. Remember that? We could add the equations together. That's what we just did here. So what's my reasoning for that? Addition property of equality. I'll just say addition property. We can add two equations together, the left and the right, and it's still true. AB plus BC. That's the whole left side of the figure if you look at the picture below. And CD plus DE, that's the whole right side of the figure below. So we've kind of lumped them together in an equation right now, but we haven't shown AC equals CE, the whole goal of this. But AB plus BC is equal to AC. So looking in my statements here, AB plus BC, that is equal to AC. And same thing on the right, CD plus DE is equal to CE. If I imagine cutting out the middleman, cutting out the D and cutting out the B. Now we're looking at the broader whole larger segments. And that means these are equal. All we did was combine the two segments. This is segment addition for our reason. And we're done. Just checking my notes. Sorry, 1 second. So we started with the given at the top. We ended with what we wanted to prove at the bottom. We did it really in just one step by adding the two equations together. And then we had to use segment addition to rename them properly, because AB plus the one next to it equals the whole. AB plus BC equals AC, and then we combine the same thing for the D part on the right, and we were done. We were able to prove that AC is equal to CE. So I don't want to harp on you guys, but I really, really hope we're at least trying to take notes on this at home. I want you to have an example of this language. Things like my reasons I used, addition property, segment addition. We're going to be using language like this and concepts like this going forward. Okay, I think we're ready for some definitions and then another example. Here we go. So let's do two definitions right now. So we'll start with this one, linear pair. And practice saying this at home with me, please. Linear pair. It's like line, linear pair. What does this mean? Two adjacent angles that form a straight line. Let's draw a picture. And what does adjacent mean? Anyone want to volunteer what adjacent means to you? And even in a non-mathy sense, adjacent. Have you heard that word before?
I think it means off. So kind of like off to the side.
Off to the side. Good. I like that. That's correct. And in a non-mathy sense, out in the rest of the world, adjacent means whenever things, any two items, are to the side of each other. In the chat, someone said, let's see, I'm not sure. And I'm not sure about that, and I'm just not connecting it myself. What Levi's saying, to the side of each other, is what. So let's add that here. Next to, or to the side. That's what adjacent means. So a linear pair is two angles that are next to each other or to the side of each other, and they form a straight line. So remember from the beginning of our Unit 7 with geometry, when we were like labeling different parts of angles and lines and planes and all that. So if we've got a straight line like this, but it's being made up of two angles. Let me label the angles here so we see them better. So our straight line is being made by 3 points in a row, A, B, C. And if we've got some other point D, now we have two different angles. We've got angle ABD, that's this one. And then next to it, we've got the thinner one that looks like a pizza slice, DBC. Let me change my color to red. Right here. Two angles, angle ABD and DBC. See how they're next to each other? They're sharing that line BD. So here's an example of two adjacent angles that are forming a straight line. If I pulled them apart, imagine if you took like a knife or a scissors and you cut right here. Imagine cutting BD in a straight line and you pulled those two angles apart, it would look kind of like this. So there again, there's ABD, and next to it, the thinner one, DBC, if we kind of separated those. They're next to each other, they're to the side of each other, they're adjacent, and they form a straight line at the bottom. The ABC is the straight line. Okay, next, let's talk about supplementary. Oh, crud. That's not what I meant to do. Darn it. That's awesome. Here, really quick, let me put my picture back up. Okay, there's our linear pair. And I'm going to write this out as part of our example quick before we do our next definition. Angle ABD and angle DBC. Remember how we name these? It's like the order of me saying ABD is telling you the direction. So A to B to D, that's telling me this angle, the first one on the left, the wider one. It's the direction, how you name it. And then next to it, DBC. Those are two different angles, and these two angles are a linear pair. Okay, so next up, let's talk about supplementary angles. Supplementary. We might have talked about this at the beginning of Unit 7, but I don't think so. So I wanted to do it today with you as well. Supplementary angles are two angles whose measures sum to 180 degrees. Sum means add. So it's basically two angles that if you added them together, it makes 180 degrees. I'm going to make an example underneath here for supplementary angles. It doesn't say anything about supplementary angles like touching or next to each other. They just have to add up. So if this one is 80 degrees and this one is 100. Sorry, here we go. Here's another one. And notice how these aren't sharing a line. We've got 80 degrees, we've got 100 degrees. These two angles add up to 180, so that means they're supplementary. Supplementary. Practice that language at home, please. Supplementary. They add up to 180. So we have talked a lot in last unit about rotations. Remember the rotations. Remember when we did our 90 degrees and then our 180 and then our 270? So when we do a 180, and we talked about this, doing a 180 is like a half circle and it's like changing your direction from front to back. So if you started facing this way, but then you turned 180 degrees, you end up facing the exact opposite way. So we know from before that a straight line like this red straight line I just made have a 180 degree measure. All straight lines are 180 degrees. I just wanted to remind you of that because we're going to use this idea. Straight lines are all 180 degrees, and we're going to use the idea of the linear pair, supplementary angles. Mix those together to try to do a proof. I want to prove now that all linear pairs are supplementary. So whenever we have the linear pair situation, that means the two angles add to 180. Let's try that one next. Here we go. Oh my God, it's almost 12. I guess we'll be finishing this tomorrow. Given that two angles are a linear pair, that's our given. Two angles are a linear pair. Prove that the two angles are supplementary. And there's no picture given. And this is sometimes common. I think everything we do in our mastery test today, or not today, we'll do it tomorrow. Everything we do in this mastery test is going to usually have a picture for us, but sometimes they don't. So we're going to practice now making our own picture based on the given and then doing the proof. So the given is only that we have two angles that are a linear pair. So let's start by drawing a diagram of a linear pair. Just like the last definition. And I'm going to label it the same way as well. So points A, B, and C are all collinear on the same straight line. And then we've got point D hanging out on top. And together, it's forming two angles, angle ABD and angle DBC. And because they're forming a straight line, ABC, these are a linear pair. And we're going to try to prove that the two angles are supplementary, that they add up to 180. Here we go. We're going to do our table again with our statements. And next to those, the reason for each statement. So always start with the given. Always, always, always start with the given. That's our main rule for today. Start by making your table and then write out your first statement. It's the given. So I'm going to say, not just two angles are a linear pair, but let's label them precisely how we labeled this because we'll need those points and names as we do this. So I'm going to say angle ABD and angle DBC are a linear pair. What's my reason? Does anyone remember what the reason is for every beginning of the proof? What's always the reason we're going to use? Can you tell me? For the first statement.
Given.
It's just that it's given. Anaya, thank you. Yes. After I asked, I was a little afraid maybe I put folks on the spot, but a little bit on the spot is okay. A little bit. It's because it's given. And that's always how we start, okay? So whenever we need to write a proof, you're going to write out the information that's given, and then the reason is given. Okay. So we're trying to prove that ABD and DBC are supplementary. That means we're trying to prove that ABD plus DBC adds up to 180. So let's get a 180 going in our proof. Let's put it in there. We have a straight line, angle ABC, the line ABC. So I'm going to start by saying the measure, that's the little m, measure of angle ABC is equal to 180 degrees. Why can I say that? Because it's a straight line. So let's say it's the definition of a straight line. And I wanted to get 180 degrees into my proof. I want to get it in there somehow. Okay. Notice how when we pretended that we cut the linear pair in half, like not in half, but along the line BD, we can cut it and remove them from each other. And then we could put them back together and it forms that straight line. It forms a linear pair. So since we're working with the separated angles already, ABD and DBC, let's say this. The measure of angle ABD plus the measure of angle DBC is equal to the measure of ABC, the whole straight line. Measure of angle ABC. So in my mind, I'm separating those two angles to show if the left angle plus the right angle, the wide one plus the narrower pizza slice one together are forming ABC, the straight line. What's my reason? Angle addition, kind of like how we did segment addition in the last one. Okay, I know it's almost time to go. Let's finish this proof, and then I want to just check notes for anyone who's taken notes, and then we'll be done for today, okay? No other homework today besides notes, just so you know. Okay, now, check this out. We have, looking at our statements, what do we have to work with? What's in our toolbox? We have the measure of angle ABC is 180 in the second statement right here. And we just said the two separate angles add up to the whole angle ABC. So we can substitute now 180 in for measure of angle ABC. Measure of angle ABD plus the measure of angle DBC, is equal to 180. I'm just rewriting statement 3. And let me label these. Statement 1, 2, 3, and 4 now. We'll have 5 coming up. I rewrote statement 3, but I substituted 180 in for the measure of ABC. Why can I do that? I use substitution. And they were already shown to be equal up in step 2. Statement 2. Substitution. Okay. And now we've got the measure of angle ABD plus the measure of DBC is 180. What does supplementary mean again? Supplementary angles means any two angles that add up to 180. And we've just shown that. So I think we're done. Therefore, angle ABD and angle DBC are supplementary. Because the definition of supplementary means two angles add to 180, and we've shown that in step 4. So this is just the definition of supplementary angles. It's what supplementary means. Started with the given, ended with what we were trying to prove, and in the middle, we've got our steps there to kind of explain why that's true. Okay, someone's already ducked out. I'll keep this screen up here, but I would like to see anyone who's taken notes. So if you have any notes, can you just show me what you got so I can check you off that you took notes today, please? Savannah with some notes. Thank you. And Anaya with some notes. Thank you. Guys and folks, if thanks, Anaya, I got you. You can. I'll still give you credit for taking notes later. If you watch the video, take your notes and send me a picture of them. Tatiana, thank you. There you are. So no big deal, but we do take notes. If you need paper and pencil, tell me in the